I just want to, before we kind of get started with announcements and everything, I just really want to address some of the responses that I was given on the survey. So number one, let's look at the muddiest points. So I am right here, just pasting the link into chat. So if you want to follow along. So number of you did mention that the for loops section was very confusing. I would say like half of you, and for good reason. It's hard. I'm still learning how to teach for loops for a beginner. I don't know if you know about the curse of knowledge, but sometimes it's hard to know what other people don't know. So we'll go over for loops a little bit more today. There'll be a few slides. So there was another comment about machine learning and its application in public health. So this is a little premature, but much like building any sort of predictive model, machine learning with statistics. So for example, if you built a regression model and you were trying to predict, it's hard for me to come up with examples on the fly, but what is the possible increase in number of infected kind of given a current trajectory? So many of the things that you can do with regression, you can also do with machine learning, but it doesn't use the machinery of statistics. That's kind of the big difference, is that there are a lot of kind of algorithms that you can use to kind of predict things. So can we predict whether someone is going to use a mask or not, given their Twitter, their tweets, for example? That might be maybe a misguided machine learning model, but that's the kind of thing that we're trying to do when we work with machine learning. Did that answer the question a little bit, at least? Whoever had it? Well, we'll get more into kind of the framework of machine learning. It will become more clear like when we get into the actual tasks. But it is, as you know, some of you may end up doing data science, being a data scientist, and so it's good to be kind of exposed to the basic concepts. So it might be something that you might actually be interested in doing further. Okay, in terms of clearest points, people thought for the most part the lecture last time was clear, so thank you. And some comments on the pacing. People seem to like the pacing overall. It was slow for a couple people. So thanks for letting me know. These are part of the Dear TED section, but I tried to just comment to just extract a few comments that weren't identifiable. Thank you for letting me know that this class is 15 minutes after biostats. So I will try to kind of keep things light and slow to begin with, so you can kind of have some time to kind of stretch your brain. And this is a major wish that a lot of people had, that this class was offered before the biostats series. So I have gone through the biostats series as well, probably about 17 years ago, and they were using SPSS at that point, but I would have really loved to have had an R programming course before the biostats. So I think this is worth having a conversation with the biostats people about this. I think it would be worth having this course be a beginning course. But again, the question that they're so kind of set in their ways. So the question is, where would we fit this in? But thank you for that feedback. So I did address this in an email. So many of the students have done the biostat sequence and use a lot of R already. So like I said, when we were designing this course, this was the audience that we were told to pitch it to was complete beginners. So just want to say, I did mention that it's okay to skip class if you can get through the lab, basically the lab and the assignment. I do want you to fill the survey out beforehand. As we get into more complicated topics, I actually do have intermediate level tutorials, and I will point you towards that. So there are tutorials and things like tidy select and row-wise workflows. So those are useful to know. Yes, so everyone seems to agree this would have been a great lab to go alongside the first class. So I think it's something, I'm a bit on the periphery of school public health, as you might guess, but I'll try to start this conversation. So Jessica Minier and we designed this course together, so hopefully she'll be able to weigh in on this again too. So, but yeah, so some toes might be stepped on, but I think it would be worth having this as an option for everyone. Okay. So were there any other points or muddiest points or things that people wanted to bring up? Okay, so now we're going to go into part 2. Oh yeah, I did want to make an announcement. How many people have heard of Biodata Club or are part of the mailing list? You can just click the yes or no by your name. Okay, you're on the Slack. Yeah, so I just want to kind of let you know about a workshop that we are giving. Just a second. And I will send information to join the Biodata Club mailing list and the Slack after class. But we are doing this workshop. Has anyone here heard of Shiny? A couple people. So have you seen any of these kinds of interactive dashboards? Like people will post a visualization and you can kind of interact with it. Yeah, so Colin's asking that's web stuff. Yes, so let me show you an example. I might as well. This might take a second to boot up, but essentially it's a way to let people kind of interact with your data in a way that's very, that gives them kind of a lot of power to ask questions about the data. So for example, here we've got a data set. It's got a lot of different columns, but you can examine kind of the distribution of the different categories within that data set. So for example, if we wanted to look at diabetes complications, you can see that 85% of the population doesn't have information, only 1% of the population does. So if you've ever heard of kind of dashboards and things like that, it's a really useful way of presenting information. And it's one of these things that it's a program built, or it's a package built into RStudio. And it's called the Shiny package. And this lets you kind of produce lots of different kinds of interactive visualizations. It's really, it's extremely powerful. So we are giving the workshop on January 28th, and it's going to be from 3 to 5 p.m. We will do our best to record it if you can't come. But you will be, even if you're a beginner, you will have enough by the time this workshop comes around in the class to participate in this. So I'll send information about the workshop and joining Biodata Club, both the mailing list and the Slack. So there's just an RSVP link. I'll just paste this into chat. Oops, sorry. So if you want to register for that, you're welcome to, and it's free. So that turned out to be the best time for most of the for me and the TAs. So I apologize if that's not a good time, but it is an option. Any other questions about Shiny? Okay. So let's get back into. Oh, okay. And the other thing I want to talk about is sorry, just too many windows open.
Hey, Professor.
Yeah.
For that workshop, is there any chance that will be recorded? Because I can't make the time, but I would like to watch it.
Yeah, so we will do our best to record it. If it's hosted, I think I might just host it on Zoom because we've had I've had a lot of issues with Echo 360, and it's just kind of a pain for us. Oh yeah, so there were a lot of questions about the function of the week assignment. So I just want to show you kind of an example of what I'm thinking about. So this is the link here. So the idea of the function of the week assignment, and I have a list of functions that I'm going to show you in a second, is that you kind of sign up and you learn about one function in the tidyverse and show people what it's for. So here, this is just basically knitted output, and when you look in the RStudio project cloud projects, this will be available, and I'll show you where that is in a second. But here I am discussing the slice function and showing what it's for. So here we'll be talking about libraries in a second, but I'm using this data set called penguins. But here, there's just basically two questions that I want you to answer. So what is it for? And show an example of how you use it. So slice lets you basically get, if you want the first 7 rows of a table, you can basically use it on a data set, and you can provide it a range. So this is short for the range going from 1 to 7. So I want all 7 rows. And this is a shorthand way of writing 1, 2, 1, 2, 3, 4, 5, 6, 7. So you can see that if you had to write all of the values out, that would be really annoying. But this lets you, that's kind of a shortcut. And so you can see when I run slice on the penguins data set, it just gives me the first 7 rows of the data. This doesn't seem that useful. And if you're a little more familiar with R, it's not that useful by itself. But like a lot of functions in the tidyverse, it's really helpful in a tidy workflow. And we'll get to that next week. But here what you can do is you can use it as part of a workflow. And you can say, I want to, for the penguins data set, I want you to slice first and return the first 7 rows. So these two values are the same, or these two ways they're equivalent ways of slicing the penguins data set, but this is much more useful. And then I just want, at the end, I want you to answer the question, so is it helpful? And do you think it works helpful? It's helpful to you in your work? So I think this is pretty helpful, especially when you just need to show the first few rows of a table. So it can be really handy. I don't use it every day, but it can potentially be handy for somebody. So I'm going to show you the project in a second, but like, you know, when you submit it, it will basically put your post up under this functions directory, this functions part of the menu, and we'll kind of, and the goal is really to kind of learn more about the tidyverse and share our knowledge with each other. Any questions about it so far? And you don't have number one question. So one thing I do want to point out, you don't have to pick from the tidyverse function list, but I compiled this list of functions. I actually wrote a blog post about it. I asked Twitter what people thought were underrated tidyverse functions. And so I compiled a lot of those. And so those are where these functions come from. So these are functions that someone thought were useful. And so hopefully it will help you out in your workflow. And this is kind of a way of expanding our knowledge together. So I'm going to go over to RStudio Cloud. And this was just added. So there is this project called function_assignment. And if you open it, it will take a second. So if you open the submission instructions here, so let's go over this. So this is kind of the process for signing up for a tidyverse function. So there is this there's this spreadsheet right here, and I'm going to explain what the spreadsheet does in a second. But this is a list of potential functions. And you know, again, if there's a function that you're interested in and it's not here, please, you can put it down in the list and you can sign up for it. I showed you the example already. So let's look at the spreadsheet. So you can see that, and we're going to get into packages in a second, but these are sorted by package, the package name and the function name. So I've done my best to basically have a short description so you know what the function gives you, like an idea of what the function is about. And wow, people have already started to sign up. Great, awesome. So what I want, so this part, this is like basically the part that we have to be on for this presentation to actually make sense, or for this function to actually make sense to you. So for example, like all of these functions right here, you can, if you wanted to present next week, you can start it, you could sign up for these functions, but you don't have to present in the week. It's just that it will be more useful to present on it if we are on that section or beyond that section, if that makes sense. So pick a week. to present. Let's just do it by like, you can do it like week 3, week 4, week 5. If you're feeling a little uncertain about what to sign up for, you can always sign up for a later week. So does that make sense? And like I said, the week of your that you can present, you can sign up for a short appointment time with me at the Calendly link. So it is this calendly.com/Ted Ladaris. And you can sign up for a 15-minute appointment. So if you're presenting next week, you can sign up. Well, let's just say you can sign up after. You can sign up starting now if you can find a time. I don't think I have much time tomorrow, but I think I will have time next week. So. And then what I want you to do when you submit for this assignment, submit both the RMD and the HTML files. And I'll add it to the web. I'll add it to the website. There's some little bit of mumbo jumbo that I have to do to get it up onto the website. But just so I know who it's from, name it like the name of the function and then your last name. So like, for example, I would name this slice_Ladaris. So finally, this is a short template that lets you, that will kind of set you up for success. There is a section in the, just a second. If you want to learn more about Markdown, this is also under the reading for this week. There is this link on the website. If you want to like kind of learn how to format things a little better, there's this option. I suggest, if you can, to use this data set, the Penguins data set. It's kind of a nice example. And if you have used R for any time, you will know that the Iris data set is used a lot. I think the Penguins data is a lot more fun. So it's already installed for you. So if you want to load up the Penguins data set in the tidyverse, you can just use this. And the nice thing about Penguins, so I'm going to open this. We'll go over kind of how to kind of access things in a second, but you can see that there are a number of different, each row corresponds to a particular penguin, and it's just their measurements and what the island they're from and the species. So it's kind of a nice set of both categorical and numerical data. So almost everything that you can do, you need to kind of demonstrate, you can probably do on penguins. And you can, so try to adapt. If you at all possible, if you can use penguins, that's probably the easiest way to go. So just kind of discussing what it's for, just answer the question, what is it for? So you may want to look at the examples for your function. So like, for example, sorry, I'll make this bigger. If you wanted to learn about slice, like for example, if you go to the very bottom, you can see that there are examples, and these you should be able to kind of cut and paste directly into R. So they'll help you kind of understand exactly what's going on with the function. So for example, I can cut and paste this. And you can see and this notation, this means we want the first row. I don't know why. I think you can just do slice 1 and that's equivalent. But that L is one way to like tell R that you want an integer. I don't really use that notation. So is only one person presenting per week? No. It's like, try to distribute yourselves over the weeks. Like, let's not have everyone sign up, like 5 people sign up in 1 week. But other than that, just kind of try to distribute yourself. Okay, great. People have started to kind of look at functions. So yeah, and again, like, if you feel like I want to make sure that everyone feels like they have enough, support to kind of present on this. Any other questions or any questions?
You might have already answered this, but on the spreadsheet where it says week to present, are we choosing that, or is it based on the part that you?
So yeah, so it was kind of hard to really kind of explain this, but the part is like, that's kind of the minimum date. So if we are on part 3, you want to present 1 3 or later. So that's just to kind of give you like, I just kind of in terms of like sent to kind of present, if that makes sense. But you can present any time after that. I'm getting internet connection is unstable, so please let me know if I'm breaking up. Did that answer your question?
Yes, it did. Thank you.
Sure. So I will say, this isn't meant to be a hard, it's not meant to be a hard assignment. It's just meant to be a way to kind of learn, learn something new and to share it with each other. So that's kind of the philosophy behind the assignment. And if you can submit this anytime. The submission is basically open till the end of the term. But, like the sooner you get it up. Oh, and the last thing is I just want you to talk, we'll open up your page on the website, and I just want you to kind of go over it and just kind of explain what it's about and just kind of field any questions. So maximum of 5 minutes presenting on any function.
Then, Ted, can you remind people where this spreadsheet lives or how to get to this?
Yes. So I was trying to figure out a good place to put this. I didn't want to put it up on the website. Just a second. So it is in if you look in the function assignment project, the link is under submission _instructions.rmd. So that's in the main folder here. I'll also post the link. I'll put the link into the chat. Just a second. So yeah, like I said, this is not meant to be a difficult assignment. It's just meant to help, like, kind of expand knowledge and share it with people. Okay, any other questions? Okay, so let's see, where do we need to go next? So I'm going to go back to classes, and I'm going to go into the part 2 section. I'll post this link just a second. So this is where, so we're going to be looking at these slides right here. So getting back on the subject of for loops, I just want to kind of show you a couple of slides, and hopefully it will become like reading for loops will hopefully become a little more clear. But again, if it's still not clear right now, don't worry about it too much. We will get back into this. But again, it's just to kind of show you that there are ways to, if you have a vector, there are ways to kind of process each value in a vector. Okay, if we started with a vector called pets. So it has dog, cat, mice. So we want to do something with each of the values in this vector. So let's start with the stuff in the curly brackets first. So these are basically the functions or the instructions that we want to execute on each value. But you can see, I should have had a different name here, but this is, so you can see it's the variable we're using is not pets, it's pet. So it's what we want to do is we want to print each of these values. So dog, cat, mice. But how do we go through each of these values? So that's where the for part comes in. And so these are instructions to R that tell R, say, I want you to go through each of these values and assign this variable pet to that. Every time we kind of go through an element, the value of pet is going to change. So the first time through, it's going to be dog. So what is pet going to equal the second time through? Yeah, cat. Does everyone see that? And I do want to go over this because, you know, it is this is something that you will see in the future. This pet and pets thing is also a little confusing, but it's instructions to R that basically says, I want you to cycle through all of the values in the vector, and I want you to put the current value in pet. So people are very quiet, so I'm not sure whether this is helping or not. So. Okay, so far so good, good. Okay. So the first pass, so the value of pet is going to be dog. And so it's going, you're going to go through, R is going to say, okay, I need to execute the instruction for that value. So pet is equal to dog. And so when you say print pet, on the output is going to say dog. And it's usually going to be kind of preceded by this bracket 1. And that's just to kind of indicate that it's a vector that's being returned. I don't recall what the reason is. But we'll do this in a second. So we found out the second time through that that the value was cat. So what is going to be printed out onto the screen?
Just be cat.
Yeah. So it would be this bracket 1 and then quotes cat. So what is like going through the third pass, the third time through, what is the value of pet? Yes, exactly. And so it's going to print out, mice here. So hopefully that was a little more clear. It is, it is like when someone tells me that they're confused, it's actually a really good thing because it forces me to think of a better way to teach it. So this was actually an interesting exercise for me. So anyone have any questions about this? And this is kind of a dumb example, but it's just to kind of show you how this works. But for example, I could have a bunch of file names here, and then I could have it load up a table with that file name, and then kind of basically do something with that table. So that's kind of that's where you can start to do really interesting things with automating concepts in R. So it's, oh shoot, yeah. So that's kind of the start of it. But when we get to part 6, we'll be kind of encountering this concept again.
Okay, so this is Stephanie. I just kind of just tried this in my console just to see what would happen.
Mm-hmm.
And so it printed, when I put like print pet or whatever, it printed dog, cat, mouse, on each
Mhm.
line with the 1 in front of it. But then like if you do it again, if you just put pet or if you put print pet, it just comes out with mouse. And I'm just trying to understand.
So this is actually, I'm glad you tried it out because this is a really good point, because this for loop just kind of cycles through the through all of the values, and because you hit the last value, it's not going to change because you're not cycling through it anymore. So this is not going to, it's always going to end out as mice. So I'm going to show you this in RStudio Cloud just a second, but I just wanted to have the just kind of talk about it with some slides. That was probably clear as mud, right? But do you get the general concept? Okay. So this is, you might have noticed I have a lot of slides from Alison Horst, but this is just kind of a cute one. So here's an example. So she's got parade, and she's got, the parade contains these different monsters that are shaped differently. And so here she's going to say, so if the shape of monster is a triangle, so you can see that's the first, second, and fourth ones. So we want to give the monster sunglasses. Otherwise we just want to give the monster a hat, and then we'll print out what the monster looks like. So what is the what is going to happen to the monster in position 3? Yeah, hat. So because it's not a triangle, it's going to get a hat. And so you can see right here, the hat is there. So we're not going to get into if and else statements right away. Again, that's going to be part of part 6. But it is it's kind of a powerful tool that lets you kind of make, do things conditionally based on some sort of some sort of condition. So like, for example, here we're looking for if the monster has a triangle shape. And then you have the option of saying, well, what happens to everything else? So that's what the else statement is. So we won't be using this at least until part 5 or part 6, the if else statements. So that's just kind of extra stuff. Any questions about loops? So this is also in the RStudio project. So I'm going to go into part 2. Looks like almost everyone's got their projects up and running. So there is this section, part 1, more for loops. And this basically has the same images if you just want to refer to them. And we'll just wrap this up and then we'll take a 5-minute break. Okay, so you can see that let's run this little bit of code. And what Stephanie was pointing out is if you look at the value of pet, or you can also see it in the environment, it's mouse, because we went through all of the different values. Let's see. So this is a pattern that can be useful in R. So what we're going to do is we have these miles per gallon readings for different cars. So 20 miles per gallon, 30 miles per gallon, 44.2 miles per gallon. And we want to convert all of those into miles per liter. So to do that, we need to take each of these values and divide. There are 3.71 liters in a gallon. I think this is right. And then what we're going to do is we want a vector where each of the values corresponds to the miles per liter of each of these values in miles per gallon. So this is kind of a common pattern in a lot of computing languages, is that you start with an empty vector. So it's a vector, but there are no values in it. And if you try, like, for example, if I just kind of run that command, and I try to run length cars MPL, you can see it has 0 because it has no values in it. And if you look in the environment under cars underscore MPL, the value is null, and it tells you that means that the vector is empty. And this is kind of a weird thing, right? So we used our C function. Remember, C is short for combine, and we used it, and we didn't put any values into it. So that is one way to kind of say that I want you to create a vector, but don't put anything in it yet. We'll add it as we go on. So what I want you to do is I want you to tell me what is happening on line 51. What's going to happen? What's the value of that at the first pass? Yeah. So that is going to be 20 divided by 3.7. So roughly 4. I can't do arithmetic in my head. Let's just run it and you can see what it is. So what is the length of cars underscore MPL after we oh, okay, and I forgot this last little bit. So one very common pattern is that you can add a value to the end of a vector. So remember, we start with an empty vector, and we can use the combine function to combine that with the current miles per liter value. So this says glue glue this value to the end of the vector. So at the first pass, remember the vector is empty, but after we do this assignment to cars MPL, it's going to be length 1, and it's going to have the value of 5.39. Yeah, thanks for posting that Byron. And then as you kind of keep on going through each of these, it's going to add the converted value to the end of that. So at 30, cars MPL looks like, so cars MPL just has one value in it. So that would 5.39. And then we're going to add the next value to it. And after that pass, cars MPL is going to be length 2. And then finally, we've got cars MPL of length 2, where we add the final value to the end of cars MPL. So what's the final length of cars MPL? Sorry, I meant the length. Three. Okay, so I just want to get to. So Sarah, do you want to talk a little bit more about that? I'm trying to understand.
I just don't. Since you're going through a loop statement and adding every MPL to the cars MPL, why do you have to have the argument of the original cars MPL? Wouldn't just going through the loop add to that list?
Yeah. So if I'm going to clear my workspace. Just a second. So I'm going to remove this. I'm going to comment out that line. So if you try to run this, it's going to give you a cars MPL not found. So we needed to define it before.
Sorry, I meant in the loop function.
Yeah. Mm-hmm.
Yeah, sorry.
So why do we do this? Is that what you're asking?
Yeah, why do you have to include that with the MPL? Mm-hmm. Why can't you have the MPL in the combining function? I'm sorry, I forget what it's called, but the concatenation function.
Yeah, so are you saying why do we need to have cars MPL here?
Yes. Why does taking that out keep you from creating a list?
Because, and this is something, this is kind of a subtle point, that if you just put MPL here, it's just going to assign that value into cars MPL. So it's going to, the first pass, that cars MPL is just going to be a vector of length 1, and it's going to have a value of 5. Sorry, I can't remember. And it's going to have a value of 5.39. So let's see. Oh, okay. So yeah, I mean, basically, you're just if you don't do this first part, you're just reassigning MPL into cars MPL, and it's only going to be the current value that you're going through in the loop. So let's just run this. Come on, why are you not? Why are you? So let's look at so cars MPL. If we just assigned it MPL, it's just going to have the last value of our calculation. So that's why we need to grow the cars MPL. So we're taking the first time, it's, so if we run this again, hopefully this, don't know why R is not being picky right now. So I did that cars underscore MPL. What the? Oh, okay, I need to fix that. So I need to run all of this code. So you can see that when we do that, when we concatenate with the original set of values, we're adding that value to the end of cars MPL every time. Does that make sense? It's a little bit of a subtle thing.
No, I keep trying to like change what that first argument is, and it keeps coming up wrong. And so just as a rule, if you're trying to fill an empty list or vector, you have to add the original variable name in the for loop.
Yes.
Okay.
Yes. And well, we can talk more about that later. So we're at 406. So why don't we come back at 410? So just take a break, unwind a little bit, and I will see you back. And if you have any questions, please post them in the chat. For loops. See, that I want to talk about. Can everyone still see my screen?
Yes.
Okay, great, thank you. Is that this is, you might note, if you're more familiar with R, you might know that you can actually just divide the entire vector by 3.71. And then you can do the same thing. So this is cars, we're taking the whole vector and we're dividing it by 3.71. I don't know why. I'll have to relaunch this in a second. I'm just going to cut and paste this down here. And you can see it produces the same output, a vector of length 3. So there are a lot of functions in R that are vectorized. So if you give it a vector instead of a single value, it knows how to handle that. So in that case, with the division function, we can, it just knows that we want to divide each of the values by 3.71. So even though most of R is vectorized and we take advantage of this, for loops can still be pretty useful. So that is, that's all about for loops. I'm going to relaunch this project because it's giving me an issue. Oh, and if you have an issue with your project, it's taking forever to load up, you can always reach out to me or Eric. But the number one thing to try is if your project is frozen, you can hit this relaunch project. And it's under the 3 dots right here next to the gear. And just hit relaunch project. And yeah, it's going to give you a warning, but that's okay. Hopefully you saved everything before. And that's the other thing I will say is I would like you to save frequently when you're working. It's just kind of good practice. So this is just going to take a second. So now we're going to get into part 2. So I do have these are all of the pictures in here that I'm going to show you in part 2 are in the slide deck as well, if you want to have them as reference. Okay, so I'm just going to run the first 2 code chunks. This just brings up the video from the previous class if you want it. So let's talk about today's learning objectives. I am now on line 27 right here. So by the end of the session, you should be able to import spreadsheet style data into R as a data frame. And then we'll learn and understand more about properties of data frames, especially variables in the data frame. You'll install new packages to your RStudio Cloud installation. And then we're going to use 2 of those packages to gain an overview of your data. And then finally, we're going to end with looking at numeric vectors in the in our data set using ggplot2. So just a brief note is now that we have gone into, we're now going to use what's called the tidyverse. How many of you have heard of the tidyverse? I'm going to clear all. I'm getting some yeses. So the tidyverse is the set of, so this, just when we talk about libraries, libraries are bits of external code that are external to what's known as base R. So when you just load up R, it has a number of functions built into it. Libraries add more functions that let you kind of manipulate things. So tidyverse itself, it's a set of libraries. And the nice thing about them is that they're really kind of designed to how people work. So a lot of each of these libraries within the tidyverse contains functions that are either essential for data wrangling, or it definitely simplifies the process of data manipulation and data wrangling and visualization. So in your project, we've already installed tidyverse for you. That's kind of the nice thing about RStudio Cloud Projects, is that you can just kind of jump into things. So now we're going to click on this play button here, and we're going to load up the tidyverse. And we're going to load up an additional library. When you load the tidyverse, it loads up not all of the libraries in the tidyverse, but kind of the main ones. But we're going to be reading Excel spreadsheets, so we're going to be using this library called readxl. So let's do that. So I want to talk a little, we didn't talk about this last time, and I want to really kind of talk about the structure of projects. So because this is really important. So every time you open RStudio Cloud, you're in a project. And the project always has this particular kind of format. So you can see where, like, and this is what is a little confusing about Cloud, is that the base folder is always called Cloud, and the project within it is always called Project. This is different from RStudio Desktop. But the most important thing is to note where this project.rproj file is. And where this is located, this is known as the root folder of a project. So it's always going to be defined by where this file project.rproj is. So everything, like if you have a file in the same folder as a project.rproj file, it's going to, you're going to be able to refer to other files in the project based on the same location. Okay, I'm not explaining this very well. Okay, so this is like, for an example, so we've got this, like, let's look at part2.rmd. So it is in the same folder as, it's in the same folder as project, the rproj file right here. So that means if we wanted to grab an image or data set, let's look at the data folder first. So you can see we've got a number of folders in here, or a number of files in here. Some of them are Excel files. Some of them are SAS and SPSS format files. But if I wanted to refer to this file, so say this smoke_complete file, in my script, I can refer to it as data slash, in this case, it would be smoke_complete dot, dot xlsx. So this is really important because if you move these files around, how you refer to files, and this is what's called a relative file path, because it doesn't have the full file location in it. So like if you are on Windows, for example, it might be C, and I still store all my projects in a folder called code. So C code slash whatever the project name is. And then, it would be data slash smoke complete. The reason why relative file paths are important is that it lets you share projects with others. When you've got these kinds of absolute file paths that are based on your file system, it actually makes things, if people try to run your code and you're trying to load up that Excel file, for example, it's there, and it has an absolute path to something on your machine, like the full path, then that code is going to break. So in general, like try to relative paths when you're kind of building projects, and you will be able to share them. Like you'll be able to zip up this project folder. Someone can download that project folder, and then if they have the same libraries installed, they'll be able to install it to run your code. So this is something, it seems really obvious, but like, I spend some time talking about file systems because I think it is really important. So let's try this out. So say we're in part2.rmd and we want to refer to something in the image folder. So how would we refer to this for_loop.jpg file? Yeah, but if we wanted to refer to the file, the actual file, so we wanted to refer to the for_loop.jpg. There's just one little bit that you have to add to the end of it. Yes, exactly. So image slash for_loop.jpg. Does everyone see why that works? And if you don't, this is a good time to ask these questions because I like to try clarify this. Yeah. So no, don't be sorry. It's something that's you sort of have to see kind of multiple times. So let's start at the beginning. There's actually an example in here. So notice that this is in the same folder as the .rproj file. So we are in part2.rmd. And so here is an example of what we want to, and this is a command that basically says, I want you to fetch this image and show it in the note in the document. So here it's so that the file we want to set is it's in the image folder. And it's this project2.jpg. So how would we refer to this JPEG file? So the project2.jpg. Yeah. Although just make sure that your capitalization is correct. So, but yes, that's the idea. So this is important because this is when you have an R Markdown file, the relative path depends on the location of the R Markdown file. So the safest way to kind of keep things sane is to keep your Markdown files in the root folder of the project. If you need to put them somewhere else, next time I'll talk about this package called the here package, which actually makes your life, it's hard to explain until you kind of get used to this. Okay, so Martin's question is, so you don't need to include the whole file path. So yes, exactly, Martin. So you just have to include the part from the file with your rproj file. And that is if your RMD file is in the same folder. Okay, so absolute versus relative. Okay. So let me see, it's easier if I show you on my, so this is an example, and if you were on, I do apologize, but this is kind of an example of an absolute path. So an absolute path, it gets you from the very, like what's called the bottom of the file hierarchy. It gives you the location, the exact location. So in this case, our path would be, our absolute path would be C/code/SPR programming site/static/slides/image/week2. So this is actually our website. So you can see that this is how I manage. And if I didn't have manage all of the files on the website, and if I didn't have kind of a systematic way of saving things, it would be very difficult. So the relative path has to do, the relative part is relative to what your current location is in the file system. Like, so for example, you can see I've got this 02-4loops.rmd file. So in this case, I can refer to the image files in here as image week2 /tidy data. Yeah. So what I am going to recommend, Amanda, is that you try to use relative paths as much as possible. Please. It takes some getting used to, but once you get used to it, it's actually like once you kind of get used to the way they work in a project, it will make your code a lot more portable and let other people use it. Eric, do you have any other things do you have any other perspective on absolute versus relative file paths?
Just to, I guess, yeah, if you're familiar with playing with this like GUI version or the more graphical way of thinking about it, it's very similar to how you might reference certain files. And yeah, relative is probably safer if you want to like give this file to somebody else versus having the absolute path, which is very specific to your own computer. So
yeah, Sarah's question, relative paths are in the folder of the project. Yes. So when we're talking about projects, they're always going to be relative relative to wherever this .r project file is for the project. And that's kind of wherever this is. So this is always going to be known kind of as the root of the project. And this is where I recommend that you put your R Markdown files, at least for when you're getting started. These are all good questions, and I find, this is a little bit of a slippery concept. There's a video in the reading. Just a second. If you look under readings, week 2, there is this section called absolute and relative file paths. So this is, again, sometimes I don't explain things completely in a way that might resonate with you. So there's a great video in here that you can kind of read up on. But I just wanted to kind of introduce you into this basic concept. Questions about projects? Okay, so why don't you think, if you have any questions, just kind of think about it, kind of mull it over, and I'm always happy to answer questions later. Okay, so I spent a lot of time talking about projects, but that kind of gets into kind of project organization and kind of keeping things together. So it's really important. Like when I do an analysis project, I basically have the data stored in a folder called data. And that to me it's just it's kind of a standard way I standardize my projects. And it makes things a lot easier for other people to find things. So like, for example, your data folder usually contains like the raw data. So someone gives you a spreadsheet. So that's where you need to process it. So that's where that spreadsheet would live. So for example, and so you can see, so we're going to be at this TCGA clinical data file. And so when we load it up, we can use in our R Markdown file, we can use data/TCGA clinical_data.xlsx. So that took a long time before we even got to loading data, but I think this is an important thing to think about, especially kind of when you're starting to work on projects in R. It's very useful. And one of the questions I get all the time, well, what about really large data sets? So you can try to store it within a project, but a lot of the times, for example, if we had what are called BAM files, so these are alignment files that for short read sequencing, we might not store the BAM files, but we might store the summarization of the BAM files. So I can't remember. Eric, do you remember I can never remember what the.
No, I'm not sure either.
Well, there's basically the idea is that version is kind of a smaller version of it. It's not the raw data, but that would be the version that I would probably save in my data folder. So is everyone thoroughly sick of me talking about the data folder? So let's actually get started. So what I'm going to do is I'm going to load this file using the read_xl function. And you can notice that this is how I'm referring to the tcga underscore clinical data.xlsx. So we start with data slash, and then the file name. So, and if you want to look at this file, you can, this is the Google Docs location, so you can take a look at it. And you'll need this in a second. So what we'll do is we'll use this read_xl file. And part of your job is to figure out what these arguments mean. So you can see now we've loaded something into our environment, and it's called BRCA_clinical. So when you load in tabular data, you can, this is a nice trick about R, is like if you click on the name in the environment, you will see like a spreadsheet-like view of the data that you just loaded up. So let's take a look at the Excel doc. So what do you notice about, what do you notice about this file? So are the column names on the first line?
No, they are not.
Yes. And so this is endless, this is an endless frustration. Someone usually, they're like, oh, like I need to tell people what this table is about. So there's usually like notes up here. So to actually load the names of your variables in a table, you need to skip this line. So anyone have any idea what argument we're using to skip that line?
Should we use skip?
Yes. This isn't a trick question. So what about sheet equals 1? Why are we using that? Yeah, so Sarah is saying multiple tabs. So that like when you're, so the sheets are actually numbered. So you can see that we've actually got multiple tabs. So if we were trying to load in this LUSK tab, what would the value of sheet be? Yes, 3, exactly. So it's going to read them in order. So if you know the name of the tab, you can also use that as an argument. So that's kind of the cool thing. So I could say sheet is equal to BRCA. So let's get rid of it, and so we can convince ourselves this works. And you can see that we loaded the same data. So there are 2 ways to kind of refer to a sheet. So this final argument, the NA, this is a very important because this is how you tell R how you coded your missing values. So for example, like if it's coming off an instrument, and these are things I hate, is like things might be coded like 999. This is the way a missing value might be coded coming off of a lab instrument, for example. I hate that, but that's, you know, you kind of, when you're working with different kinds of data, you kind of have to adapt to it. But in our case, the missing values, so let's look for an example of missing values. So you can see under the days to death column, our missing values are coded by just the capital N and capital A. Okay, so let's do this challenge. So what I'm going to do is I'm going to create some breakout rooms. So what I want you to do is take a look at the documentation for readxl. And I want you to answer these questions. I guess, actually, yeah, so I guess you only really need to answer the third question because we already did that. But okay, so actually, why don't you read the documentation and just let me know what the guess max argument is before. Yeah, so Amanda is saying a maximum number of data rows to use for guessing column types. And this can be important because what the readxl does is it basically tries to scan through the data. And it says, okay, I'm going to look at the first, so if you use guess max is equal to 1500, it's going to look at the first 1500 rows, and based on those values, it's going to guess the data type. So Stephanie is asking, Max, so I'm assuming whether it's character or numerical. Yes, exactly, Stephanie. And also, there's also it can guess, like if you have true false values, it can guess that Boolean data type that we talked about. Sometimes it can guess whether it's categorical or not as well. So it's based on the first, I think the guess max argument, the default is 1500. So it's scanning through the first 1500 rows to give that, to guess what the data type is for a column. Okay, so that took a long time to actually get the data into R, but there's a reason why I spend a lot of time on this, is because I find, when I first got into R, I tried to get my data in and I was very frustrated and I gave up for a couple of weeks. And it was just very frustrating. And I know a lot of you work with Excel files. Well, we'll talk about SAS and SPSS formatted data as well. But we start with Excel files because I think a lot of people do use them. So any questions about file loading so far?
Yeah, I've actually got one. What if the person who made the Excel document decided that they wanted to include one of those helpful notes, like below all of the data instead of above it?
Yeah, so that's sometimes that's a good question. Let's look at the documentation. Maybe there is you can stop. I think there's an n max. So there's this n_max argument. So maximum number of data rows to read. Its value is usually infinite. So that just means scan through the entire file. So if you wanted only the first 1500 lines of your file, you could set n max is equal to 1500. So that's one way to get around it.
Okay, that makes sense. Thank you.
So read_Excel, there is a lot to it, but these are kind of the basic things you should need to know to kind of get data into it. So now I'm on the section on line 117 called Notes on the Data. So I just wanted to mention where this data comes from. So this comes from a project called the Cancer Genome Atlas, but it's actually hosted at this place called Genomic Data Columns. So Cancer Genome Atlas is basically data on a number of cancer patients and a bunch of different cancer types. So for example, lung cancer, so that's LUSC, cervical cancer, that's CESC. And in this data set, each row represents a patient, And each column represents information about some sort of demographics of our patient. So age at diagnosis, what their race is, and then, you know, what their cancer type is. So this was not, this data was actually had to be processed to get it into this format. So Kate Hertwick, my friend Kate, so she did a great job kind of getting the data into this format. But if you're interested in looking at the code that she used to transform the original data set into this Excel file, it's right here. Okay, so now we're going to, let's actually assign breakout rooms. So I'm going to make 10 breakout rooms. So it's going to be 10 people per person. And so let's take 5 minutes to work on challenge 2, which starts on line 123. Oops. Sorry, let me try to do that again. Okay, I'm going to open all of the rooms. So let's take 5 minutes to work on this exercise. If you did. Okay, I see some yeses. Are there any questions about this?
Why did you have the code on lines 139? I just made my own. Did you want us to make our own?
So this was just to give you a start. So
okay.
That's, you know, when you're first starting to learn this, I just wanted to kind of give you a head start there. So if you can do it on your own, that yeah, you don't need to.
Thank you.
Sure. Any other questions? Do you all feel more comfortable loading data into R, or still feel uncomfortable?
I think it makes sense. One question I guess I have is when I loaded the data and then ran the chunk, it has a bunch of lines below it that says new names, and it has a bunch of lines that say not reported to not reported or something like that. Do you know what that would be?
Can you share your screen? Just a second.
Let me see if I can.
I need to give you the power. Just a sec. Yeah, you should be able to share screen.
Hold on. Let me, so I have it open on a different computer. I'm trying to think of a way I can show it to you. Maybe I can turn on my camera and actually just turn my screen around or something. Yeah.
Okay. So, well, let's go through the first one. So what is the value of sheet? What should the value of sheet be here? Oh, sorry, and I'm not sharing the screen. So for the CESC clinical, where did chat go? Yes, so sheet is equal to CESC. So what about skip? And you can also use 2 as well. No need to skip. So we can, if we don't need to skip, we can either delete that. Actually, that's probably the easiest way to do it. Or you can just say skip equals 0. So let's run that code. So again, like clicking on the data. So we do confirm that, like, we've got the column names and we've got the values. So there's a lot of NAs in here like before, but it seems to have been loaded incorrectly. Does anyone want to post their code for loading in the Lusk file? So it's going to be read_xl.
I could show you what I put and also show you the errors. I just got it loaded up on this computer I have Zoom open on.
Okay. Can you, okay, let's take a look. Yeah, can you, wait, sorry, that's mine. Okay, so new names. So for the, I think what happened is that you skipped when you shouldn't have.
Oh, you're right. I didn't even notice that.
So this is why I make you do this, so like you kind of learn, right? So try it again.
All right. Oh, there we go.
Okay, so let's go back to sharing screen. Anyone have any questions on this part? Sorry, I'm just rearranging my windows. They're all over the place. Where's chat? Yes. Any other questions on readxl? So why don't we take a 5-minute break here? Come back at 5 o'clock, and then we'll talk about tips on formatting Excel files. Started again. So let's talk about some tips on formatting your Excel file for R. So who here has heard about tidy data? So it's a way of formatting data, Bradley. So he's asking, is that different from tidyverse?
Is this just best practice or a package?
It's best practice. So let's talk about what tidy data is, because the tidyverse is dependent on you making your data tidy. It has a lot of tools for you getting your data into R and then making it into a tidy data format. So I mean, that's part of why it's called the tidyverse. So what is tidy data? So simply, and this is why we were talking about vectors last time. So each column in a tidy data set corresponds to a variable, and each observation is a row. So for example, for ID 1, this cat with ID is equal to 1, its name is Floof and its color is equal to gray. And so for ID 2, the cat's name is Max. So each row is an observation. And this is one thing that can be really difficult. So each cell is a single measurement. So we'll be talking about this. And if anyone took the separate rows function, this is something that solves a problem when you've got multiple values for an observation in a column. But for the most part, this is kind of the format that Tidyverse is expecting. And we'll be getting into ggplot2 in a little bit once we talk more about kind of the data sets. So again, thanks to Allison Horst for sharing that image. So let's kind of talk about some tips for formatting your data in Excel. So I wanted to set you up for success so you can get your data into R. So like we said, tidy is best if you can swing it. And in our examples, so for BRCA_clinical, each row corresponds to a patient, and each column corresponds to a variable of clinical data or demographic, and each of these cells has a value. Sometimes, you know, you're working with someone and they want all of their variables to be in rows. Well, transpose is really your friend in Excel. So you can basically, you can make a new sheet, and you can basically, you know, cut and paste and use transpose to kind of get the data into a more tidy format. This is another one that's important. So every column, if you want to analyze it as a variable, every column needs to have a name. Every one of your columns should, so each of your columns has to have a name. And this is one thing with R, is it should begin with a letter, if at all possible. So don't say, like, you know, for example, 4x. You might want to use x_4. So just be very careful with numbers and special characters. And by special characters, I mean things like, well, you don't want to use backslashes, but things like stars and things like pluses and things like that, because these mean special things to R, or dash. Dashes can also be, dashes can be okay, I think, but for the most part, you don't want to try to kind of avoid these known as special characters. The one other thing is that I know this is like, oftentimes we are very visual, but if you're using color information, it's really hard to get into R. I had to write a couple of Excel macros to get, because one of our collaborators was using color coding for things, and I had to figure out how to transform that data. So if you can, maybe you might want to, instead of, because when you're color coding a column, for example, that's actually two sets of information that you might say. So, like, you know, like say you are highlighting the ones that you think are good samples, and you're using a column called ID to do that. That's actually two different pieces of information. So if you can, try to make that information that the color is represented in its own column. Finally, extra lines are okay, as you saw. And, you know, a lot of the times, at least I find it kind of good practice, if you need to have something like a data dictionary or notes on the data sets, I tend to have it in a separate sheet, if at all possible. So any questions about this? Has anyone encountered any of these situations? Okay. Well, I just want to, this is part of the reading for today. So this is a wonderful paper. It sounds really boring. It's called Organizing Data in Spreadsheets. But come on, it starts out, this is the opening. Spreadsheets, for all their mundane rectangularness, have been the subject of angst and controversy for decades. If people are interested, we can talk about this paper a little bit at the beginning of the next class. But it is actually a really great paper. And I send this to all of my collaborators just so they're kind of aware of all of the issues. So it's a nice paper. Okay, so this is one last bit of tidy related wisdom. If you're familiar with, I believe it's Chekhov, this will be funny to you. If not, it's still kind of funny. So standard structure of tidy data means that all tidy data sets are alike. So, all three of these different tables, they have the columns as variables and rows are observations. But every messy data set is messy in its own way. So this is sorry, it was Tolstoy, I believe we said, every happy family is alike, but every unhappy family is unhappy in their own way. So that's where that comes from. So here's an example. My columns are values and my rows are variables. I have variables in columns and in rows. I love this little guy at the end. I don't even know what my deal is. Okay, so any questions about tidy data? Okay, so we've been kind of skirting around this, and we've been talking about, we've loaded our data in a tabular format, but here's where we're tying together what we learned with vectors with the way the data is organized in this table. So the main structure we tend to use in R is this tabular format, and the formal name for it is a data frame. In the tidyverse, it's also known as a tibble, but for the most part, we're going to be calling them data frames. So Data.Frame. So what is the deal with a data frame? So number one thing is that each table contains vectors. And what do you notice about the vectors in this CESC table? Are they, let's look at an example. Are they all the same data type? No. And that's one of the most powerful things about data frames, is that you can mix both like numeric and textual data. For example, if I had like a response to a survey, and actually this I do work with a package called Qualtrics to kind of extract all of the survey stuff. And so for each cell might be one of your responses to a question, and this column might be a question. So this is a very kind of flexible format to store data. So while vectors need to be all of the same data type, a data frame can contain vectors of all different data types. So when you're loading data into R, so let's talk about properties of data frames. And these are just useful when you're loading data and you want to confirm that you're loading things incorrectly. So the very first property, so now I'm on this section called data frames. How do they work? On line 288 or 228. So the first thing I might do is I might check the dimensions, and you can check the dimensions with the dim function, and you just run it on the data frame we loaded. And it gives you the information. So it always starts with the number of rows and the number of columns. So there are 1,095 rows and 16 columns. And if you look in the environment, you can also have confirmation of that. It just, the terminology is different. So it's called observations and variables here. Okay, so I think we got the data incorrectly, but one of the things is, especially when you're dealing with skip, did you skip the right number of rows? So you will, it's always good to check what's called the head. So this is just the first few rows of the data set. And you can see that it returns by default 16 rows or 6 rows. And to see the other columns, see, like I'm basically pressing on these little triangles here. So that gets me to the next set of columns in the data set. So another thing that we often need to know is like the names of the variables. So you can use this call names function. So this will return all of the names of each of the columns. So you can see by using column names, we're returning a character vector that is the same length as the number of columns, and it has all of our column names. I do want to note that you can look at row names as well using the row names function. But in general, when you're loading data in with the reader and readxl, you tend to not have row names for your data set. So it tends to not be that informative. Usually it will give you like basically a number. So like 1 for the first row, etc. Okay, so we've been kind of beating around the bush. So this is a really useful function to actually get a general overview of what the values are. So there's a function called glimpse. So any idea what character type submitter ID is? Yeah, string or if you can see here, it's character, CH. So CHR is short for character. And remember we talked about the difference between kind of numeric and double. So in this case, the default kind of guess is that the value is stored in a decimal format, even though these are integers. And you can see that age at diagnosis, this is weird. But this has to do, I believe this is the age in days. So glimpse is a very helpful function because it will kind of give you an idea of what kind of the way data is represented in each of the columns. So for example, you can see morphology is represented by this 8520/3. So there's a slash kind of, and it needs to be represented as a character. So we'll also, if you want to use, view is also a very useful command. When we actually click on these data sets, it's actually a shortcut for view. But if you click on view, you'll see it opens up the table view. And there's some nice things that you can do with this when you're just kind of browsing things. So say I wanted to look for a status alive, it will highlight all of the rows that have that status. But again, this is you're not meant to do many things with it, but it's often useful for visual confirmation. Okay, so there is a built-in function in base R called summary. And sometimes it's helpful and sometimes it's not. So for example, we see tumor stage is represented as character. So do you think this is a categorical variable or not? Yeah, this actually should be a categorical variable. So, but as a default, our reader and readxl load things that look like characters as characters, but you can convert them to the data type in R that's for categorical data, which is called factor. We'll talk more about this next week when we get into doing box plots, because it's an important thing to know. So, but you can still see that we get some good summary statistics. So for days to death, we can see the minimum value was 116 days. So how many missing values are there in the days to death column? Yeah, so if you look under NAs right here, it's 945. So there are 945 patients in our data set, which is actually the majority of our patients that don't have, well, this is a good thing because it means that they're alive, or they were alive when this data was captured. When you ran the code, you just have the length, class, and mode for days to death. Okay, so Sarah, make sure that you you loaded the table incorrectly. That looks like it's a, yeah, I'm not, we'll have to look at that. Maybe we can look at that during a break. I'm not sure what's going on there. It should, yeah, it should be a numeric variable, and it should be giving you that information. So now we're going to actually install a package. So this is a package that comes from my buddies at ROpenSci, and it's called Skimmer. And it is a very useful package because it is very intelligent in how it handles data and gives you summaries. So summary can be helpful, but a lot of the times Skimmer is actually a better version of summary. So let's install it. And remember, you only have to install a package once. So once you run install packages, you can load up the library or load up the package using the library command. So I'm going to install this package. So hopefully, if you open your console, you'll see it's going to go out and install it. And why are you taking so long? Okay, so you can see that we are installing the Skimmer package. If you have a question about what packages are installed in your R installation, you can always go to this packages.tab. And if we scroll down, and one handy thing is you can see which packages are actually loaded up with this check mark. But if we look, go down here, we can see that we just installed the Skimmer package. So again, now that we've installed the package, we can call it with the library function, and we're going to run skim on our data. And this is, I just find this, this is not part of the tidyverse, but it's just so useful that I show it to everyone because I think it's a really useful way to kind of start out with your data. So for example, you can see like for the ethnicity category, this is a character variable, but it kind of tells you like what are the number of unique values. So this can help you identify when you've got character variables, whether they're categorical. So if there are 13 unique values, it's a lot less than 1095, then that's probably a categorical variable. The other thing I really like about Skimmer is it gives you these really compact histograms. So you can kind of see the distribution of your numeric variables. So for example, age at diagnosis, you can see is pretty pretty normal looking, but days to death is very much left skewed in this case. So that's a really useful package. So now we're going to install another package, and it's called VisDat. And I find this to be a really useful package to understand missing values in your data set. So let's install it. Any questions about packages while we're at it? Okay, VisDat has a bunch of, so this is just a way to kind of visualize a table, but it's really helpful because it kind of can alert you to patterns of missingness. So we're going to run VisDat on our BRCA clinical data set. And then sometimes, this is just a quick tip, if you want to learn about a package, usually maybe you can use the help function and you can attach dash package to the end of the name of the package, and sometimes usually it will bring up more information about the package. But we're going to use this viz_dat package. And this package is from my friend Nick Tierney. I just find it super useful because you can see not only what are the data types in a data set, but you can also see whether they're missing or not. So any of these gray values are missing. So does it make sense that years to death and days to death seem to have the same values, that present values? Yes, because they both have to do with death. But this is just I find it to be like, especially when I'm communicating with my collaborators and I say, look, there's all of this data missing. Like, is there something going on here? It's a very powerful tool for kind of communicating that. Okay, so we're going to end with ggplot2. So are there any questions about Skimmer or VisDat? Okay, so let's get into ggplot2 then. And again, thank you to Allison for this is, I love this visual data exploration, and you can see all of the different graphs have wings, doing lots of different ways of representing data. So now we've got our data, we've ensured that we loaded it in correctly. So we're going to start doing things with the data. So let's start visualizing the data. So I'm now on line 369 here, working towards a graph. So this is a graph we're going to start working towards. Sorry, this is. You can see that it is a scatter plot of age versus days to last follow-up. And it is colored by the points, individual points are colored by gender. So we're going to build this up from scratch. So who here has heard of ggplot2? Are people just completely zombie?
I would say this is actually one of the parts that I'm more interested in, just because of the amount of hours that I've spent trying to get ggplot to work for my other.
Yeah, so hopefully now that we've set you up for success, you'll be able to get ggplot to work with your data more consistently. So this is what we're going to be learning about today. So ggplot, you need tidy data, and you need to map these columns, these variables, to what's known as an aesthetic. So an aesthetic is a visual property. So it can be like, for example, like a position on the x-axis. So that in this case, so we're mapping our GDP variable to our x-axis. And then for our y-axis, we're using life expectancy. And then finally, so once you have that kind of aesthetic mapping, you can impose what's called a geom. So a geom is short for geometry. And in this case, because we want a scatter plot, we're going to use this geom called geom_point. So that's kind of the basic structure. So let's actually start talk about ggplot2. So there was actually a really interesting interview with Hadley Wickham, who is the author of the ggplot2 package, among other people, but he started it out. And the GG in it is short for grammar of graphics. And so it is a way to kind of express statistical visualization. So a ggplot2 graphic consists of a mapping of the variables in your data set to the aesthetic attributes of geometric objects. So let's take a look at an example. So the first thing we're going to use is every ggplot starts out with using the ggplot function. And then you provide the data as an argument. So here we're using BRCA_clinical. And now here we're going to make our mapping. So here we use this function called AES, and AES is short for aesthetics. And here we're providing we want to map age at diagnosis to our x-axis, and then y is equal to days at birth. And notice these are all chained together with addition, with pluses. So we take ggplot, we're telling ggplot that we want to use BRCA clinical. So we add the extra bit about the mapping using the plus and the AES function here. And then finally, we need to add the geometry. So we have another plus here, and this becomes geom_point. So when I'm reading a ggplot statement, I tend to read the pluses as then. And when you're starting out, I encourage you to start looking at code and trying to read it out loud. Amelia McNamara, she's another great educator, and she talks about kind of verbalizing R and how it helps people to start to read and understand code. So now what I want you to do, so let's do the challenge. We can just do this right here. So we want, based on this graph up here, I want you to map the appropriate variables to the different aesthetics. So we've got an x-axis here and y-axis. And remember, your variable names need to be exact matches for the variable names in the columns. So when you're done, just hit done or type in done in chat. So a few people are done. So let's get started on this. So what did you map? What variable did you map to the x-axis? Age at diagnosis. So did it have spaces in it? Yeah, it didn't have spaces. So age underscore at diagnosis. So what did we map to the y-axis? Yeah, days underscore last. Okay, so let's try it. Let's try this out. Shouldn't take that long, but that's the way it is sometimes. Okay, so you can see that we already started to kind of recreate our graph. One thing to notice is that, again, age at diagnosis is a number of days, so we need to fix that. And our x-axis and y-axis titles are not like the previous graph. Did everyone, so just let me, are there any questions about this? Okay, so let's fix this issue with age at diagnosis. So this is a trick. I don't recommend you do this in general. I actually recommend that you process the data. But this is one trick we can do just in the meantime. We can actually divide age at diagnosis by 365 to get our age in years. So if we run that, you can see now our age at diagnosis is much more understandable, but now our variable name is called age at diagnosis 365. So that's a little bit of a setback, but at least we're on the right track. So this is the one of the last little bits. So what if we want to map gender to color, what do we put here?
Could you do either fill equals gender or color equals gender?
Yeah, so that's a good question. So that is actually dependent on the geometry. So if we were using a box plot, we would use fill to fill in the boxes. But in our case, if you look, and I'll show you this in a second, if you look at the entry for geom point, you'll see that it doesn't have a mapping to fill. So here we have to use gender. So we're getting closer. So now you can see we've colored things by gender. And of course, because this is breast cancer, it is much less common in males than it is in females. It still occurs, but that's why the majority of these cases are male and female. Okay, so now we can use this function. I think So we can add a title to our graph. So I am using this labs function. And you can look up the documentation for labs. Labs is short for labels. And we're just providing a title here. And so you can see now we have age versus days to last follow-up. So I think this is the final thing. Sorry, this should be. You can use GG title as well, but I kind of use labs in general. So here we're just using xlab and ylab to add our axis titles. So if we run this, you can see now we have changed our axis titles. So we've recreated the plot. So this is just kind of a whirlwind introduction to ggplot. But again, I want you to kind of focus on the first three kind of sections: the ggplot, the aesthetic mapping, the AES, and then the geometry. So let's look at the documentation for geom point. So this is kind of a good thing to point out. So not all geometries have the similar aesthetics. And the way you find this out is you kind of go down, you look at this and you look at the aesthetics entry. And so, oh, I guess it does understand fill. So I learn something new every day. But you can see you can map all of these different kind of aesthetics. Like you can map point size to a variable. You can map fill and color. So alpha is transparency. So you can map, values to kind of how transparent like the point is. So that when you're putting together an aesthetic mapping, it's always good to look at the geom documentation so you understand what's going on. So any questions about that? So the final thing we want to do is we want to save our plot. So we're going to use this function called ggsave. So you can, ggsave is smart enough that it will basically save the last plot that you made. So let's take a look at files. So I'm going to go back into our project directory. So let's see where does this graphic get made. And it's also smart enough, like, so if you wanted a PNG file, you could put in PNG here and it will save it in PNG format. So where did it save our plot? Did it save it in the root folder or did it save it in the image folder? Yeah, so Jessica is like, it's saved in the project folder, exactly. So if I wanted to save it in the image folder, how would I change this? Yeah, so Bradley is saying, so you add image follow-up plot. So if we run that and we look in the image folder, you can see now we created that follow-up plot in that. If you want to view it, you can always just click on it and it will show it in a view. And you can also download it using that trick we learned last time. So you can click on it and you can click export if you want to save it. Yeah, so Yeah, Jessica, exactly. And I think it's smart enough if you used JPEG instead of JPEG, it's smart enough to know that that's also a JPEG. Okay, so this was kind of a lot of material. Do people want me to go through loading SAS files and SPSS files?
I'd be interested in staying for that.
Okay, so what I will say is if you're tired and you want to get the hell out of here, you can watch this later. But please take the survey again. Eric will send out a reminder. But this section is pretty short. But so if I would completely understand if you want to get out of here. So it's been a long day, I'm sure, having taken biostat before this. So I'm just going to finish up. This is just one little section. So one thing that you need to know, so Jessica wrote this section and I just realized that we haven't talked about this $ notation. So this is a way to extract a column from a data frame is by using this $ operator. So if I type in BRCA clinical, you'll see that all of the different variable names pop up. So if I wanted the age at diagnosis and I wanted to return it as a vector, I can do it like that. Okay, see you later, Eric. Someone please just remind me to stop the recording at the end of this. Okay, so that's basically how you can extract you can extract a column as a vectors with this $ operation. So in general, we're not going to be using this very often, but I just want you to understand what's going on here because Jessica uses this. So this package that loads in data from other statistical packages is called Haven. It's part of the tidyverse, but you do have to load it in separately. And so we've got, we saw that there was this data set. So there is a data set, and this is in SAS format. And forgive me, I'm not really a SAS user, but I can at least show you some of the basics. So we load in the Haven package, and there's a function called read_SAS, and we provide it our SAS data. And you can see that our data was loaded in as a data frame as expected. So for SPSS files, the function is called read_SAV. And for Stata, the function is read_DTA. So one thing to keep in mind is this reads all of the data in as tibbles. Or data frames. And so you can also export the data using the write underscore versions of this. So for example, if you wanted to save it in SPS format, you can use write underscore SAV and write underscore SAS for the SAS format. So one thing is that, one kind of headache about this is that there might be labels or attributes for individual columns. So just basically, so if you want to learn more about how to deal with these additional attributes, there's this link here on reading this semantics article. So now we're going to read in this really large data set. So you can see it's 53.8 megabytes. So that's not trivial. So we're going to use read_sav to read it as the NAMCS. It's going to take a second because it's a big data set. So when we run glimpse on this, and this is just for the first few columns, you can see it has a special representation called DBL plus label, LBL. So this is a numeric value, but it's actually categorical data. So how do you actually get at the labels? Because this is encoded in numeric format. You can actually look at, so if we just type, if we're just looking at that race on variable, and we're just going to print the first few values of that, you can see that it returns the vector here, but it also returns this data frame, and this data frame are the labels, the actual labels for the values. There is a function called zap_labels, and I think that's supposed to basically make the numeric values into the categorical values. I don't know it offhand. If you're interested in learning more about that, you can sign up for it as a function of the week, but I don't really know that much. So there is this function called str. This is short for structure. So this gives you more information about this race UN. And so it gives you more information about the label. It tells about, so patient race was unimputed. It gives you an idea of what the format is and the labels. So this is just a little bit about kind of converting. We haven't really talked about factors yet, but we can actually don't remember what this part is about. Oh, okay, so this will let us actually recode everything. And if you use this as factor function, and we haven't gotten to mutate yet, so like we'll come back to this, but this is one way to kind of recode the numeric values into the character values. So this is another, if you're having issues with labeled data, this is another great article. And let's just kind of summarize things. So we loaded Excel data. We learned some ways to format our data in Excel more successfully. We looked at basic properties of data frames, and we looked at the basics of the grammar of graphics. So again, please take the survey. Eric will send out a reminder tonight. And if you want to further practice your ggplot2 skills, you can take the first chapter of the R bootcamp that's available here. Okay, so Bradley was asking the question. So all of those versions of the read function just using the file extension. So actually you need to specify, that's why we were talking that they have different names. So based on the data type. So for example, this one, the SAS one uses the read_SAS file, SAS function. Hopefully that makes sense.
Yeah, that answered my question. Thanks.
Yeah. So that's it for today. If there are any questions, just please make sure you get your assignment in. I think last time I checked, it wasn't, everyone hadn't submitted. So if you need any help, I'll stick around for a little bit in case you're having trouble getting your HTML file out of R. So have a good night, everyone.
Thanks. Don't forget to turn off the recording.
Thank you.